y'all. I just wanted to take a quick second and go over a couple of questions that were on your quiz 6-1 before you take your requiz. I'm going to go over a couple where the most points were lost overall on the quiz, and that's going to be the inverse question. So there were two questions that asked you to find the inverse of a function and asked you to restrict the domain if it was necessary to do so. And it was necessary on both of the questions. And I had very few students who actually did restrict that domain. So I'm going to just go through how to find the inverse and then how to know whether or not we need to restrict it and what that restriction is going to be. So this first question says f of x equals the square root of x plus 2 minus 3. Restrict the domain of the inverse if necessary. So our first step would be in finding the inverse to change f of x to y. And then we are going to switch our x and our y. So we have x equals the square root of y plus 2 minus 3. And then we are going to work reverse order of operations, moving everything away from the y. We've got to isolate the y. So I'm going to first add 3 to both sides. I get x plus 3 equals square root of y plus 2. And then to get rid of that square root, we are going to square both sides. So I saw a mistake right here from some of you where you just put the square on the 3 or just on the x, but we want to square this whole entire thing over here. Now, we don't have to actually physically multiply it out, meaning we don't have to do x plus 3 times x plus 3 and distribute. We're just going to leave it in vertex form. So we're just going to leave it as x plus 3 to the second power. The square root and the square cancel out on the right, and we're left with y plus 2. And then we would subtract 2 from both sides, x plus 3 squared, with a minus 2 on the outside, and that's equal to y. So we can rewrite this as f of x, or actually f inverse of x, I should say, equals x plus 3 squared minus 2. Now, I told you we would need to restrict the domain. So if you recall, when we were dealing with inverses, we said we always want to restrict the domain of our quadratic, of our parabola. Because if I have a square root function like this, and I reflect it across the line y equals x, like this, let's say our quadratic looks like this, reflected across that line, your quadratic also has a second side of the parabola. So by restricting the domain, we're saying, hey, these two functions are inverses, but only this right side matches up with the square root. So by restricting the domain, we say, hey, we want to throw half the parabola away. This is the part we're looking at. So your restricted domain is always going to be equal to the range of the square root function. So if we look back up here to our square root function, our original function, we could say the range here is y is greater than or equal to negative 3, because it's y is greater than or equal to our d value, because we don't have anything that's reflecting this over the x-axis, so it's going to go up and to the right. So our range is y is greater than or equal to negative 3, which makes our restricted domain x is greater than or equal to negative 3. Or we could say from negative 3 to infinity. Okay, and that's always going to be your c value, because if you recall, right here, this is going to be our vertex, negative 2, negative 3, which makes the vertex of this parabola. We're going to switch our x and y coordinates, negative 3, negative 2. So our domain is going to be everything to the right of that vertex, or x equals negative 3. So our second example is almost identical. I'm going to go ahead and change this to a y. We get x equals the square root of y minus 3 with a plus 5 outside. So we're going to first start by subtracting the 5. X minus 5 equals the square root of y minus 3. I'm going to square both sides. We get x minus 5 squared equals y minus 3. Once again, no need to multiply out that x minus 5 squared. We're just going to leave it like that so that our answer ends up in vertex form. When I add the 3 across, I get x plus 5 squared plus 3 equals y. And then, of course, we can change this to f inverse of x. Okay, once again, this is our quadratic. So we are, whoops, I somehow changed that to a plus 5 along the way. And it should be minus all the way down. Okay, sorry about that. All right, so we need to restrict the domain of our quadratic, which again happens to be our inverse function. Sometimes it might be the original function, but here I have the squared term, so this is the one we need to restrict. We're going to come back up here to our original function, where our range is from positive 5 to infinity. Okay, remember we always check for our a value to make sure that it's going up. If we're going down, you would need to make it less than that value. So therefore, our restricted domain, oops, our restricted domain is going to be x is greater than or equal to 5, or from 5 to infinity. Okay, one last thing where some of you lost a couple of points, and this wasn't as big of a point loser as the inverse, but when you draw your square root functions, there's one in particular that asks you to graph the parent function and then a different transformed function. Okay, when you graph them, you need to make sure and put arrows on the ends, because if it just looks like this, oops, if it just looks like this, I can't tell necessarily which end is the starting and which end is the ending point. Okay, so we need to put arrows and endpoints to show our direction of travel. And you just lost 1 point per arrow, so it, like I said, it wasn't that big of a point loser, but it is a way that we could gain a few extra points on our requiz.